we're going to start finding roots for our polynomials, and we're going to focus mostly on the real roots for now. When we start looking at imaginary roots, then we'll first look at just imaginary numbers so we can deal with those before we actually try to find the roots. So far we've learned a lot of skills that we're actually going to apply to help us find roots. Factoring is one. Okay, if you can factor a polynomial, all you do is you set each factor equal to 0, and that'll give you your roots. Long division is going to come into play in this lesson. So if we can determine, where some roots are, we can divide those out so that we have a simpler expression to solve to get the remaining zeros. All right, so let's start by just figuring out how many roots we should be looking for. Polynomials are always going to have the same number of roots as the highest power of x, okay? And that's total roots, so this isn't necessarily real roots. I'll be able to show you how to find out how many real roots you have. But if I have this first equation, I know it's going to have 6 roots because my highest power of x is a 6. Okay, this one's going to have 2 roots. Sometimes you're going to have repeated roots, which means it's going to bounce off of a root, so that one counts for 2. If it goes through, that counts for 1. Now, the real roots are always going to be in this form, p over q. Okay, p is a factor of the constant term. So this would be our p from this equation. So we'll take factors of it. Okay, so in this one, my factors would be 1, 2, 3, and 6. Okay, and those are all possible p values. Q is a factor of the leading coefficient, so q comes from here. So my possible ones for that would be 1, 2, and 4. So let's look at all the possible roots that this one has. Okay, so possible p values, like I said, was 1, 2, 3, and 6. These are all possible p values. Q values are going to be factors of 4. So we have 1, 2, and 4. So the only possibilities we have for real roots of this equation are the combinations I can make when I put a p over a q. So I can put, and all these are going to be positive or negative possibilities. So I can put 1 over 1, so that means possible roots would be positive or negative 1. I can put 2 over 1, so I have plus or minus 2. I can put 3 over 1, so I have plus or minus 3. I can put 6 over 1. I can put 1 over 2, so positive or negative 1/2. 1 over 4. Let's see. I should stick with just one bottom q value first. So I can put 2 over 2, which is 1 again, and I've already listed that, so I'm not going to list it again. I can put 3 over 2, so positive or negative 3/2. I can do 6 over 2, which is 3, and I've already listed that one. I can do 1 over 4. I can do 2 over 4, which is 1/2 again, which I've already listed. 3 over 4, which is a new one. Or 6 over 4, which is 3/2. So these are all the possible roots. 2, 4, 6, 8, 10, 12, 14, 16 possibilities for what real roots I could have. When we start trying to find these roots, actually, we're gonna make it easier on ourselves and use the technology we have at hand. We're gonna use our calculator. I'm just gonna plug this function in here. 4x to the 6th minus 3x squared plus 6. Okay, I'm going to graph it. I'm going to make sure I zoom to fit the whole thing, so zoom fit. Okay, make sure I can see above and below the y value, so I want to get some negative y's in here. Okay, and I'm really only looking for the zeros, so let's just go a little below and a little above. Okay, there's no reason for me to look at all these different y values if I'm only looking for where my graph crosses 0. And it's not. There are no 0 values. I can confirm by looking at my table. Okay, So I don't have any that are going. Okay, they just keep getting bigger and bigger and bigger. So even though I have 12 possible real roots, this one doesn't have any real roots because my graph, if I just will zoom fit again, okay, it's never actually crossing. I guess I'll make it a little bigger so it's more noticeable. Let's make it negative. It's still not big enough. Let's add some more zeros on here. I've got 1, 2, 3, 4, 5, 6, 7. Okay, so it's never actually crossing my x-axis. So this one has no real roots. Okay, that's as close as it gets. All right, let's look at some more. So here's basically what the rules are for finding roots, and the ones for the first part are going to be a little simpler. When we're just looking at real roots, it's going to be a little easier for us until we get into the all roots. The first thing you want to do is you want to graph or make a table to look for the easy roots. And you're going to use your possible roots to really help you define your table. So when I do the next couple examples, you'll see what I mean. You're going to divide out the roots you find. Okay, so we'll go through that. We'll use long division to divide out those factors. If you have a quadratic left, then you're going to use the quadratic formula. If not, find possible roots, real roots with P and Q, and divide them out. And then keep going until you have a quadratic or something you could factor. So let's do this first example here. I'm going to do it kind of a couple different ways. So I'll go through the whole problem, and then I'll come back and do it a different way that helps you find roots a little bit easier. So the very first thing I'm going to do is I'm going to plug this into my graph. Okay, so there we go. Let's zoom fit to start. Okay, and then I want to see what's going on around my y-axis. So let's change this so that I don't see quite so many. I don't need to see all that stuff down there. Let's see. Negative 4 up to 4. So right there I've got 1, 2, 3, 4 zeros. I should have a total of 4. So that means all 4 of my zeros are real. So let's look at my table and see if I can pick some out. Okay, there's 1, and there's another one. So I have a root at -1 and +1. So when x equals 1 or x equals -1, those are 2 roots, 2 of my 4. So before I teach you the trick, let's see what we would do just knowing those roots, how we would use that to help us find our other roots. Well, if x equals 1 is a root, that means that x minus 1 is a factor of this function. If x equals -1 is a root, that means x plus 1 is a factor of this function. So it's up to you if you want to do 2 long divisions. You could divide by this first. You should get no remainder. Okay, because this is a factor, so it should come out evenly. And then you could take your answer and divide by this. Or you could combine these together and just divide by their product. So if I combine these, I'm going to get x squared minus 1. So if I want to, I could just divide by this, and that would be dividing both roots out. So I'm going to do this because I just want to do one division. So I'm going to divide this by x squared minus 1. So I need to match this. So I'm going to times by -4x squared. That's going to turn this to +4x squared. Okay, I want to put that underneath my x squareds. Let's go through and change both my signs. So these cancel. This is going to come down. Okay, and then I've got 39x squared minus 4x squared, so that gives me positive 35x squared. Now to make this match, I'm going to have to multiply by 4x. Okay, so again, this 4x that I'm getting is going to go underneath this. So really, I should have brought both of these down. Okay, so that comes from there. I'm taking 4x times this to get 4x cubed minus 4x. Change both your signs. These go away. 35x squared comes down. This cancels. That'll bring the 35 down. And then I just have to multiply by 35. And that's going to get me my no remainder. So now what I've just done is I've taken out this factor. And it left me with my answer here. Negative 4x squared plus 4x plus 35. So now, I know that this represents these two roots that I had. I need to find out what this represents. So you can solve this any way you want. If you really like completing the square, complete the square, set it equal to 0. If you want to use your quadratic, you could use your quadratic. But if you're doing quadratic, make sure you don't just plug in your calculator because we want exact answers, so you're actually going to have to do the quadratic out. Or you could try to factor. I don't know if this one factors. We can try it. Yeah, let's try to factor this. I'm pretty sure it does factor. So I'm going to take a negative out just to make things easier for me. So I'm going to take that negative out. So negative 4x squared minus 4x minus 35. And this is going to turn into, let's try 2x and 2x. So 35 is 5 and 7. If I do 5 and 7, I'm going to get 10 and 14, which are 4 apart, so that's perfect. And I want the 7 to be negative. So that's what this factors into. So I'll put my other factor here and put the negative out front. So this one, again, represents these two roots that I found. In order to get my other two roots, I'm just going to set these other two factors equal to 0. Okay, add the 7, divide by 2, I get 7 halves. Subtract the 5, divide by 2, I get negative 5 halves. Those are my 4 zeros. This one, 1, and negative 1. Okay, so that's kind of the whole process that we're going to do, and that's going to stay the same process. We're going to try to look for some zeros. We're going to divide those out, take our simplified answer, and try to get more zeros from it. All right, let's look at a trick that we can do to maybe eliminate the need to divide altogether. Okay, if I look at my P and Q factors here, I can see that my possible zeros, okay, so for 35, I'm going to have factors of 1, 5, 7, 35. Okay, for my possible bottom numbers, I'm going to have 1, 2, and 4. Okay, factors of 4. So that means if I really wanted to, which I'm assuming most of you will, I know that my denominators aren't going to be, they're either going to be 1, which would be a whole number, which I have right now, or 2, which would make me have halves, or fourths, which would, give me a 0.25 somewhere. So if I make my table go up by fourths, okay, that'll cover the halves and the wholes. Okay, so I'm just going to have my table go up by 0.25. So now if I go over to my table, okay, I'm going to start to see more zeros on here. So here my end behavior, Okay, my end behavior should be going both positive. So that tells me that I haven't yet, or no, both negative. So this is getting bigger and bigger negative as I go left, which it should. So that tells me there's no zeros that way. So I'll start moving this way. Okay, it's getting smaller, it's getting closer to 0. Oh, there's 1 0. Okay, and that's negative 5 halves, which is one that I found. That's 1. Okay, as I move, there's the negative 1, that's 2 zeros. Okay, there's 1, that's 3 zeros. And there, 3 halves, which is the 7 halves. That's all 4 zeros. So if I'd been smart and used my P and Q to figure out what the denominators would be, I could get the table to list all the zeros that there were. Okay, so that's a extra trick. That's not going to work all the time, so you can't always, give up on the division. And I'll do an example where, you're going to have to use the division. We're going to skip that one. Okay, so here's one where we're still going to have to use the division. So if I plug this in, okay, so here I've got, looks like 2 zeros there, right? Because it's dipping below and coming back up. I've got a 0 there and a 0 there. So let's check my table here. Okay, so there's all 4 visible, so I have 4 real zeros. Let's see, for my table, let's figure out what my denominator should be. Okay, so I'm going to have factors of this and factors of this. So factors of 18 are 1, 2, 3, 6, 9, and 18. Factors of 1 are just 1. So really my denominator, if I have rational zeros, then they're going to have to be whole numbers. So let's check my table. There's no point in going up by 0.25. I might as well just go by 1. See if any pop out at me. Nope, I'm not seeing any here. Let's see. Okay, but there's one between here and here. Oh, it's still going up by 0.25. I don't want that. Oh, table start. I want to start at 0. There we go, that's better. Okay, because I want whole numbers in my x column. So right there, there's a 0 at -2 and a 0 at 3. So that tells me that I'm going to have some factors. One of my factors is going to be x plus 2. Okay, because if I set this equal to 0, that's how I'm going to get the -2. And my other factor is going to be x minus 3. So we could multiply these together and divide by that. That's what I did last time. I'm going to do a double division this time to show you how that works, just so you've seen both ways. So I'm going to divide this first. Just going to make some lines here. Okay, first I'm going to divide by the x plus 2. So I'm going to have to multiply by x to the third. So that gives me x to the fourth plus 2x cubed. Subtract these, and that'll cancel. I'm subtracting. So this will be negative 3x cubed. So I have to multiply by negative 3x squared, which gives me a negative 6x squared here. Okay, and that negative 9 comes down. I'm subtracting these. So those cancel. This gives me negative 3x squared. Bring the 3x down. I have to multiply by negative 3x. Okay, change my signs. Those cancel. This gives me 9x plus the 18. So I multiply by 9. Okay, and these go away. I get no remainder. Now I'm going to take my answer to that, x cubed minus 3x squared minus 3x plus 9. I'm going to divide that by the other factor that I found, x minus 3. And I'm going to divide, so multiply by x squared here. Okay, I'm subtracting. So that cancels, this cancels. So now to get this to match that, I'm going to just multiply by negative 3. That'll give me negative 3x plus 9, and I'm subtracting these, so again I get no remainder, which I should, because I saw that these were factors. So now I've got a factored form of my quadratic. Okay, I can rewrite it as the things that I divided out. So these are the things I divided out, and the final answer that I got after dividing those two things out. Okay, so if I set this one equal to 0, I'll get the x minus 2, or x equals negative 2. This one will give me x equals 3. If I set this equal to 0, okay, and solve, okay, and then square root, don't forget your plus or minus. So the positive square root of 3 and negative square root of 3 are my other two zeros. So my four zeros are negative 2, 3, square root of 3, and negative square root of 3. To check these on my calculator, okay, I can calculate some zeros. Okay, the ones that I didn't find, I'm going to calculate them. So let's see, I had negative 2, so I want to make sure I'm not quite to negative 2 there. So I'll go there, go above, and I get negative 1.732051. Well, is that negative square root of 3? Let's check. Negative square root of 3 is the same thing. Okay, so that's how you can kind of check your answer. And we could calculate the other one, and you'd see that it's the square root of 3. Okay, so we've got real zeros, rational zeros. Okay, the PQ thing is how we find all our possible rational zeros. I think I misspoke earlier and said real zeros, but that's how you find rational zeros, which are the ones that aren't going to have square roots or i's in them. You have to divide those out to find your other irrational zeros, and then we'll talk about finding all the real zeros in a later lesson. So that should be enough to get you going on the finding real zeros assignment.